Hello, this is Ms. DB. We're going to look at some more attributes of functions today. So here's some questions that we can ask and answer about a function in addition to the ones that we've looked at in the last few worksheets. Where does the function increase and decrease? Does it increase or decrease slowly or rapidly or at a constant rate? Does it have any inflection points where it changes from concave up to concave down or vice versa? Does it have symmetry? When is it below the x-axis, which we call negative? When is it above the x-axis, positive? How many branches does it have? So we're going to look at some of those in the next, in this section. So increasing and decreasing is just what you think. In this example here, a function is increasing here, and then it increases again over here. And it decreases from here to here, from here to here. So a function can do more than just one. It can increase the whole time. It can increase, decrease, increase. It could do several of these types of things. And we also will look at it within a certain interval sometimes. So in this example problem, they want you to look at when is it increasing and decreasing from -1 to 2. So here's -1, and here's 2. So they shaded it that kind of light green color. And within that part, the function decreases first and then it increases. And we can tell approximately where it stops decreasing and starts increasing again. So in this one, we have it decreases from -1 until about 1.2. They just estimated that value. And then from there, from x equals 1.2 and all the way up to 2, then it is going to increase. So here's a way that you could write that and kind of summarize it, where it's increasing and where it's decreasing. Next thing we're going to talk about is inflection points. An inflection point is where the graph changes from concave up to concave down or vice versa. Concave up is when it forms this, it's especially easy to tell on this section over here. Get a red pen here. So over here we have this kind of it would hold water, right? That's concave up. And concave down is when it's got this upside down, like a roof kind of structure. It'd keep you dry underneath it. The point at which the graph changes from concave down to concave up, that's called the inflection point. Now, it's hard to tell exactly where that point is on a graph. Maybe it's there, maybe it's a little bit lower, maybe it's a little bit higher. But we can actually use calculus, when you take calculus, to find that exact point. In this class, we'll just estimate approximately where the inflection point might be. It's a little bit harder in this graph to see. The concave down just has a slight, like, yeah, I can see that I could shelter underneath there and I would stay dry. And the concave up, yeah, there'd be some water that would kind of pool in there for a bit before running down. So, and then again, the inflection point is the point at which that changes. Positive and negative is another thing that we can talk about with functions. Positive and negative of a function refers to what is the x values when the graph is above the x-axis, and what is the x values when the graph is below the x-axis. So in this first example, this whole function is positive. For over the whole domain, whatever x is, the function, the graph, the y values are all above the x-axis. So everything's positive. In this example, the whole function is negative because no matter what the x value is, the graph, the y values, are below the y-axis. But in this function, we have both. We have some negative values and we have some positive values of the function of y. So we would say that this one is positive when x is greater than 0, because for all the values from here for x and up, the graph is above the x-axis. And for all the values less than 0 of x, the graph is below, so that's negative. So make sure that you're describing the x values and explaining the intervals of x when you say it's positive or negative. Don't answer it's positive above the x-axis and negative below the x-axis. Yeah, we know that. We want to know for this function what values of x will give you the graph above the x-axis for positive, and what values of x will give you the function for below the x-axis for negative. Some graphs are symmetric, not all of them, some of them. Like a quadratic function, you can draw a line like right here, and you would have the exact same shape on the left side as on the right side. So some graphs are symmetric about the y-axis, like this example. They might be symmetric about another line too. Like if you have the function y equals x minus 2 squared, then you have a parabola that is going to be symmetric about the line x equals 2. So they don't have to be symmetric about the y-axis. Sometimes they are, but they can be symmetric about other lines as well. They can also be symmetric about the origin. If I were to, here's the origin, 0, 0. If I were to cut and take this part and rotate it, it would land exactly on that other part. So you might call this, if you were in geometry class, you might call this rotational symmetry. We call it symmetric to the origin in algebra. Here's an example of one that's symmetric around the x-axis, but this is not a function because to be a function you have to have, has to pass the vertical line test for one. And in this one, there's 2 places that my vertical line passed through the function or through the graph. Or also you can say that this x value matched to 2 different y values, so it's not a function. For the ones symmetric about the y-axis, we call these even functions. We'll look more at this next week. And for those that are symmetric around the origin, we call that an odd function. But again, we'll look at that further. Today we're just going to look at whether or not there is symmetry. Sometimes your symmetry might come at a point or about a line that's not a vertical or horizontal line. Like in this rational function, I drew in the line y equals negative x minus 4, and we can see that if we folded at that line, this branch of the function would land just on top of that branch. They look the same, they're mirror images of each other. So what we're going to do in this worksheet is kind of put everything together that we have looked at this week. We're going to talk about where it's increasing and decreasing, when it's concave up, inflection points. Oh, concave down, I didn't bold that part, but we could bold it. Symmetry, when is it positive, when it's negative. And branches just means exactly what you would think. A rational function often has 2 branches like this one does. Some discontinuous or piecewise functions will have more than 1 branch. Rational functions even sometimes have 3 branches. And we can say whether it's continuous or discontinuous. This one's discontinuous because there's a break where there's an asymptote. So you can look back at this example that has all of those parts explained a little bit more and how to answer them. You might say none or never for some of these things, or not possible. And you're going to do this again for some of the parent functions, for linear, for quadratic, cubic, square root function, and so on. Rational. And this is the natural log function that we looked at before too. Or this is the exponential, and this is the natural log. And then for one of the functions, a, b, or c, pick one and let me know which one you're picking, you're going to answer even more questions. So for that function, you're going to say what the domain is, what the range is, max, min, all of these things that we've looked at. And you don't have to attach your graph, but you will want to graph it in order to help you decide what the asymptotes are and the max and the min and so on. It wouldn't hurt you to attach your graph, but you don't have to. Let's just look at one of these to complete. Let's look at, I wanted to do the cubic. Here's the cubic. All right, let's do the cubic one. So this is increasing from, now it doesn't matter what the arrow shows. The arrow does not mean if it's increasing or decreasing. We're going to go from left to right, and we're going to start near the bottom, and we're going to go up. And since we're going up, that means that it's increasing right there. It's not increasing on the whole thing. It looks like it goes to a constant straight line or close to it there. So I'm going to say that it's increasing from x is negative infinity to, I guess, 0. and it's not decreasing anywhere, is it? But let's go back to the increasing. Then it's going to start increasing again right after 0. But I think at 0, it's not doing either of those things. It's kind of a flat section where it's changing from concave down right here. That's concave down, and this is concave up. So my inflection point looks like 0, 0. It's concave down at the same place as my first part of my increasing, negative infinity to 0, and it's concave up from 0 to infinity. It's not decreasing anywhere. Symmetry. This has symmetry about the origin. So this doesn't have line symmetry. I couldn't cut a line and it wouldn't look exactly the same. But if I were to take this piece, cut it, and rotate it, that's symmetry about the origin, then it would be symmetric there. For what x values is the graph positive? So let's look at the positive part. The positive is when it's above the x-axis. So what we want to know is what is x from here to here when it's above the x-axis. So it is positive when x is greater than 0. Not 0, because it looks like at 0, it's exactly at 0. For what x values is this graph negative? So that is when it's below the x-axis. It looks like when x is less than 0, this function stays negative. There's only one branch. There'll usually only be one branch, unless it's a rational function or piecewise, and it is continuous. So we've answered all the questions about this function that we could. And you're going to do that for each of these. Answer the questions as best you can. Remember, sometimes there will be something that doesn't apply, like this one has no symmetry. Also, this one will never be concave up. And it's also never going to be decreasing. So it's okay that some of them will have an answer of never or none or nowhere. And then remember, for the last one, you just have to pick one of these functions, either a, b, or c, and then you'll be answering a few more questions than just what we talked about today. All right, thanks and have a great